We recently talked about the paper titled Megabyte, which was focused on leveraging transformers in a hierarchical architecture directly on the bytes of the data. Now we want to talk about a paper titled Bytes Are All You Need, Transformers Operating Directly on File Bytes, which is kind of similar to Megabyte, but is more focused on privacy-preserving features. So let's begin. If you have a sequence of bytes from your memory, this could represent an image, a video, a voice, audio, whatever. Now, this work is focused on leveraging these bytes themselves in order to create representations useful for performing different tasks via AI, which means that it's going to be focused on multimodality. Another thing that they want to address is that if you obfuscate these bytes, and for example, if you have a privacy-preserving camera or something, you want your model to still be able to learn from those bytes and perform accurately. Toward achieving this goal, they propose Byteformer, which is their architecture. Mainly, the goal is to have a sequence of bytes either before or after obfuscation, and then you will have the tokenized representations of those bytes, and you would use these representations of bytes directly in your transformer in order to make the representations ready. The important point about this privacy-preserving feature is that given that this model is going to work directly on bytes, if you do the obfuscation, meaning that if you have a permutations from byte values to byte values and you apply it on these byte values, for example, if you map FF to 1C, you could basically permute these token representations and then use the same model to do the inference on this obfuscated file. And to take advantage of that in training, they use a random permutation as well. The goal is to allow learning on the obfuscated examples as well. And of course, it's not, let's say, secure in the sense of cryptography, but it's kind of a good insight. And they explain that to avoid local regions to be remapped to this kind of regions, they also can use noise as well. So you can see noise I added, and the image here is more uniform. In the results, they discuss the great accuracy on ImageNet Top 1 task for Byteformer Tiny. And you can see the results here. K is the kernel size, W is the window size, which they use in order to alleviate the quadratic complexity of the attention mechanism, and Q is the quality factor of the JPEG. The same goes with the audio classification task, in which they get good results. They also show that under the image obfuscation that was discussed, the Byteformer model performs better than the model that was operating on the pixel values. And this holds especially for high noise. And that's it. Thanks for watching.